Assuming now it should be better, I think. Okay, so we're going to cover the statement level control structure, guys. So technically, there's 3 control flow chapters. We already covered one last time, which is within the expression itself. So we talked about the assignment and stuff. And then we're going to talk more about like the program units itself in the next chapter. But today's chapter, we're going to talk about the control flow inside or among the program statements. So what do you mean by this? We're going to check, the if conditions, the loops, stuff like that. So how is the control flow going? So as an introduction, we know that, as we mentioned before, in imperative programming, computations are performed by evaluating expressions and assigning values to variables. We already talked about this last chapter. Now, beyond the assignments that we covered in last chapter, there should be more things, right? If you want to actually write like an actual good program, you cannot just make a program which is only assignments, correct? So what do you usually, the basic stuff that you always include, you always have to have if conditions, right? Why? Because you want to be able to choose. And also iterations. So imagine, as we've talked before, you want to do 100 assignment, it's not practical. So you're going to call a loop. So these are very important things. So we're going to discuss a bit more about the design issues when designing these 2 things. What should we include? What should we avoid? So we said there is the control flow selection, which will be very useful to allow choosing among alternative paths of execution. And then there's the repetition mechanism, right? Which is mainly means loop. Now, control statements, these are the statements that provide selection and repetition capabilities essential for flexible and powerful program logic, as we mentioned. Now, again, what we're trying to do in the course is that to talk more about the design issues. For example, the control structure. So if I have a control structure, how can I evaluate this one? So what would the design question be? One of the main design questions would be, should a control structure have multiple entries? Have you thought about this before? Multiple entries. Like, for example, you're doing a loop and you can have multiple entry, not just like starts as single entry and goes until it's done. No, actually, I don't think you use it, even though there's some programming languages like C++ and other, you can have access to this. Have you, because you've taken C++, have you seen the goto statement in the C++? Yeah, so you can actually call something called goto. So even if you're inside a loop, you can go to specific something. So now you have a different entry to this loop. So it's a bit kind of very complicated. So single entry mean no, like we have a single entry, and then when it's like you're going to have an output after that, just one single. Now we're going to talk. So this was actually one of the main things. Now, as you can see, that lots of people don't even know that it exists, multiple entry, because it was proven to us that single entry is better. We're going to talk about it a bit. So what do we mean by that? Basic control structure in most programming languages, selection, the if statement, and then the iteration, which are the loops. These are designed to have a single entry point. So in the most programming languages, but this means that when the control structure execute, it always starts from the beginning of the code. But what about multiple entries? So we're going to talk a bit about it. In some languages that allow goto statements and labels, it's theoretically possible to enter a control structure from different points. So even if you're in the middle of a control structure, let's say you're in the middle of the loop, you can actually have a different also entry to re-enter it. As we said, for example, the goto to jump to the middle of a loop, or a conditional structure creating multiple entry points in a code block. Now, again, we're going to go back to the Fortran. Actually, for example, if you look here, I don't understand Fortran, but if you check the goto here, there is goto 20 and then there is goto 10. So these goto, both of them, they are considered an entry point. So inside this, we can have actually multiple entry points. Now, this was very common in the beginning when they used to have the Fortran. It was common before structured programming concepts. Then they discovered that actually writing big programs and having this multiple entry is going to cause lots of headaches, lots of complicated stuff. And there was much research, there was lots of research, lots of discussion in the 1960s and even also in the 1970s about this specific thing. So like they took lots of time to prove or to come into a conclusion that no single entry is better, and then they moved. So thank for Corrado Bohm and Jacopini. So I'm not sure if you've heard of Bohm and Jacopini theorem. It's called Bohm and Jacopini theorem. This is actually a theorem where they were able to prove that if you don't include the goto in a language, then all algorithm represented by flowcharts can be coded with only two control statements, selection and iteration. So if we get rid of the goto, then we can have everything represented by either a selection, which is the if conditions, or an iteration. So we solved a big problem. So made things much simpler for us. So why multiple entries are generally avoided? So what can we conclude from this? As we mentioned, so why would it be, if you want to look at it from what? From the readability, reliability, all these other things, Michael? Very good. So if I want to look at something from a readable perspective, if I want to evaluate the readability, if you're looking at something that in the middle of a loop can go to a different one, it makes readability harder, correct? Okay. What else other than the readability? Ibrahim.
Well, just like usually we have execute the code like line by line, so like you have like the go to assignment, like the flow of the execution.
The flow of the execution, definitely. So multiple entry disrupt the flow of execution, making it harder to understand the program. But also because of this, you'll have a problem with maintainability. So if you want to maintain, even if this is reliable, even let's say, okay, even with the goto, it's still reliable. It will be consistent and everything. We will not have errors, but to maintain it is going to actually be harder. Why? Because it's harder to even understand. It's harder to follow the execution. So code with multiple entry points tend to be error prone and more challenging to debug or modify. So if I want to debug it, it's much harder for me now because I have to follow it from place to place. It's not as clear. So it's harder to predict how the code will execute, especially with nested control structures. So now, as we said, modern practice will discourage using the multiple entry, even though, as we said, in C++ and C, we still have the goto, you can still use it, but it's discouraged to use it inside a control structure. And because how important it is to make things, better with a single entry, you'll have like Java, Python, JavaScript don't even allow it. We don't have the goto inside the Java, for example. And this will help, it's similar when we talked about Java, about strong typing, for example, right? Java doesn't even allow you to do the coercion because they want to, as much as they can, to maintain the better design. The same thing here, they don't even allow the goto. Now, this is the structured program theorem. So this is, again, that's the theorem that we talked about that was proved by Bohm and Jacopini. It's divided into three things, not just two. Of course, we have the if condition and the iteration, but then we have something much simpler. We're not going to spend much time, which is the sequence, right? If you just have sequence of assignments. This is very simple. Three fundamentals. The sequence is just executing things one another. Then we'll have the selection, which is for the if condition, and then the iteration for the loop statements. Now, for the sequence, the only thing that it's worth mentioning here is that even if you have sequence of stuff, what is the abstract for it when it comes to a flow control is that we have one single entry, one single exit, right? That's how it is, like, because we know they are sequence, they don't have to take any decisions. So we're going to look at it like there's a single entry, single exit. Now we're going to spend a bit of time on the selection statement, which is the if conditions. Again, each time we want to, there's some stuff that you may not have noticed, but I combined it from different programming languages. Small differences, we're going to talk about them. So what is the selection statement? It provides the means of choosing between two or more paths of execution, and there's two general categories usually for the if statements. There is the two-way selectors, which is what? If, else, correct? But there is the multiple way selectors. What is a multiple way selector? Rahim? Switch, exactly.
If, like, for example, in Python or Java, they have if and else if.
The elif. If, elif, exactly. So that's also considered a multiple way selector using a two-way selector. So if you use the two-way selector to build a multiple way selector, you're going to use this, or you're going to use just right away to a switch cases that's an actual multiple way selector. So the two-way selection, we're going to talk a bit about it and talk about its design issue. We're not going to talk a lot about the multiple way. The two-way selection looks like this. So what would be some of the design issues for a two-way selection? There's three main issues here. The first one is that we want to check, or we want to decide what would be the type of the control expression, right? So I have a control structure. I need a control expression. So like, for example, I'm saying if I need a condition, correct? So the type of this condition was actually one of the design discussions that they are having. Should we allow, for example, only Boolean, or should we allow other than Boolean inside this if condition? Another one was, how are the then and else clauses specified? So we're going to talk about it. Should we allow something to be without brackets, or we should have it strict for brackets? The third one was, how should the meaning of nested selectors be specified? Also, we have the if, then, else. So for example, this else, how does it follow the if there's a nested if? So we're going to talk about it more with some examples. So the design issues, if you want to explain them, the first one, the form and type of control expressions, it's about the nature of the condition and the if statement. So some languages allow any non-zero or non-null to present true, while other requires a strictly Boolean type. And even if you remember, in the old C, we couldn't even use Boolean. So we had to use the arithmetic one. We had to represent any non-zero as true, for example. The specification, the second design issue, if you want to explain it a bit, is in some languages, the then and else clause must be clearly marked, while other might use indentation of braces. Who can think about a language that actually use indentation? Or yes, Python, for example. Python. Why? Because again, if you remember, when they designed Python, they want to make it as flexible as possible, as easy as possible, as user-friendly as possible. Even though this will sometimes have the drawback of what? Making some mistakes, making some errors. It's easier to make an error because you don't have lots of check, like syntax stuff. Now, the third one, which is the meaning of nested selectors. We're going to talk about it. When if statements are nested, the language need a rule to decide which if and else belongs to. So we're going to talk about it. So let's start with the first design issue, which is the type of the control expression. There's two main things. The syntactic markers are what? If there is no reserved word, like then, to introduce the then clause, many languages require that the control expression be enclosed in parentheses. For example, Ruby, I think they have the end. So you have to put end. Like when you have like if something, you have to say else, and then you have to say and after the else. So this is actually one of the, they are enforcing you to have some of the things. Other languages, they don't have this thing. Now, this is what we're going to focus on here, because there is a bit of difference between the popular languages, which is like C++ and Java. There's a bit of difference between two. So the arithmetic control in languages like C89, C99, Python, and C++, the control expression can be an arithmetic expression, not just Boolean. That means if I say if X, and then I do the statement, it will work. I don't have to say if X is less than 0 or if X is greater than 0. It doesn't have to be Boolean. It will actually work. But in other languages, like what? This will not work. Do you know if in Java it will work? Java usually strictly Boolean, actually. And again, you're going to see that Java is one of the languages that they have the strong typing things. There's lots of syntax stuff that they will focus a lot. Why? Because they wanted to make it as reliable as possible. So when you're running the compiler, it will catch as much wrong things as possible, so you can fix them before having problem. So, and this is based on what? On the design. When they were designing the Java language, they had one of their main goals, for example, to be as reliable as possible, for example. Python, maybe the main design was as flexible as possible. So why would having explicitly Boolean be a good thing or a better thing? Why do you think? We mentioned a few things now, Michael. Readability. But there's something, actually readability, yes, because it will make it easier for me to know what's happening. But what else, which is the more important one that I was talking about now? I just mentioned it. I was talking about Java, yes? No. We said Java does the strong typing and all things. Why? Because it wanted to be reliable, right? And this is through what? Type safety, because we're talking here about types. That's why I'm mentioning, yes.
Like the other languages that allow expression, they like implicitly convert it to Boolean.
Yes, so I'm going to show you an example now, and you will get what I mean more. But actually here, having it explicitly Boolean or only Boolean, it will add clarity, for example, better readability, and also type safety. We're talking about types here. So type safety, what leads to more reliable thing. Now, if we want to take the example, so let's take this example. If I take this code, this is in C++, okay? And let's go to outline. So I'll make this bigger. And we'll go to C++. Is it big enough for the student on Zoom? So look, int x equal 5. If I say this, if just x, I don't do anything. If x, it will actually what? Work. This will print because x is non-zero. This will not print. Why? Because x minus 5 is what? Is 0, right? So 5 minus 5, that's 0. That means if it's equal to 0, if it's not true, do this. So they can use just this. So it will be any non-zero integer, any non-zero, it will be considered true. Any 0, 1, it will be considered false. So that's how C++ will work, yes. So let's try it with Java. Where is it? So let's go here and try this. So now we're going to go to Java. And let's look here, guys. So I have int x equal 5. So let me uncomment this. Okay. So I'm saying if x system print, this will not compile. Will give me an error. So how do we usually do it? We're going to have to check if x is not 0, do this. So that's the way Java, for example. So that's the difference between Java and C++ and C. So they pay attention, or they focus more on the type safety of things. Now, why would this not be good if there is just a mistake here? Yes.
Place X5, the integer is 0, would that also run?
Let's see. I don't think so. Like, you can say if 5, because this is 5, right? It will not work, I think. And let's say if 0, it's the same concept. So it will not work because it needs Boolean. So if you say if true, it will work, for example. So let's go back. So this is a good thing when it comes to, this is like a good design when it comes to this type safety thing. Now, the second design issue that we're going to take a look at it is the close form. So this is also something I'm not sure if you've noticed it when you're doing Java. Single or compound statements. What do we mean by that? We mean that if you have an if and the condition, can you have two statements under each other? And yeah?
Like the if expression going forward for a while, you have like one single statement in like a bracket.
Very good. So if you've noticed it before, sometimes you're going to notice it while having an error and you can't find the error. Where's the error? And then searching a bit, you're going to discover this thing, right? Oh, I cannot have more than one statement when it comes to the Java. We're going to see an example, unless I use brackets. Now, if you took the ITI 1121 or something, that's why usually whenever you learn a language, like in Java, right away they will teach you what the good practice is. They will tell you always put brackets. Why? Even though it will work without the brackets, but sometimes it will not work. So the good practice is always to follow these rules so you can save yourself. So now in Java, we're going to check an example. In many modern languages, then and else clauses can be either single statements or compound statements. We're going to check it. And language-specific requirements. For example, Perl requires braces for all clauses. So this is a design decision that the people who designed Perl took. They said, you know what? We don't trust programmer. They will be lazy. They will not include, even though we're going to tell them, oh, it's very good. It's very important to use the brackets. Very important, but then they will not do it. So we're going to enforce it. What would this help? If you're using Perl, this will help you what? So where would you catch the error? At the compiler time. So if I'm catching the error at the compiler time, that's very good for me. Like I didn't include the brackets. Okay, you know what? I catch it at the compile time. Python and Ruby use indentation. So we're going to see it. Actually, they don't need brackets. Benefits of this now, not the disadvantage. We know the disadvantage, we talked about it. It may not be very reliable. But what is the benefit of just having the indentation? Yes. Readability, actually, if you look at the Python code and you just have the indentation, it looks like, very structured, especially that if you're using the, let's say, the notebooks or something, they even show you the indentation, right? It helps you see it. So making the syntax simpler and enforcing readability. Now let's take a look. So this is Perl. Perl will not work without the braces. Python actually support the two statements. So because it's based on indentation, what's going to happen? X equal 2. If X is greater than 3, print this, print that. Both of these will be read as part of the if, just because they are on the same indentation. Now, Java actually disagree with us. Okay, so let's see. If I go the Java compiler, in the Java compiler here, I'm saying int x equal 2. Okay, so that means and my condition here, if x is greater than 3. So that means, should these two be executed? Technically, no. Technically. Why? Because x is 2, so x is less than 3. So both of them shouldn't be executed. So let's run it. It executed the second one. Why? Because here, as I said, Java only support single statement. So under the if condition, only the first one will be for the if. The second one, it will be as if it's outside the if condition. Now, how can we fix this? That's it. We'll just put the brackets and it's going to be solved. That's why it's recommended. It's a good practice to always use the brackets, for example. So you can actually solve it with the brackets, as simple as that. But again, all of these different languages, each of them, they have a good advantage for this design decision that they made, maybe disadvantage for another design. Also, by the way, C++ and I think C also, they all have the same idea of Java. Now, let's go to the third design issue when it comes to the to the selection control structure. What is this in front of us? Very good. Who remembers this grammar? Is this grammar ambiguous? We spent so much time on this, right? But now we're going to be able to use it. That's why we spent time on the grammar. We were talking abstract. I know it wasn't making sense a lot because we were just talking abstract. But now let's see actually what happens. Is this, Ibrahim, why is this has ambiguity in it? Why?
What they say when you have like them statement, but then you don't know, like you have like them statement, you don't know if there's an else after that, you don't know.
In another way, if we look at this, that's, for example, let's say I'm using this grammar, okay? So let's say this Java-like code is using this grammar. So this is my first statement. If sum equals 0. So I'm here. That's my statement, correct? So I'm here. So this start with if, and the other option start with if. So I have two options. If I'm going randomly, let's say I chose the first one. So if I choose the first one, this first sentence will be this if logic expression, okay? But then this whole thing will be the then statement. Now in this case, that means this else will be for this else, if. But if I go to the second one, it has if, then else. I'm going to go, this is my if, this is my statement, and then this is my else. So this else now is for the first one. So there can be what interpreted in two different ways. And that's why we said back then, we should not allow this to happen by having a clearer grammar, correct? And that's what each programming language will fix this problem using their own way. So they may have different rules for this. For example, what can be a rule for Python? Python decided to solve this issue by indentation, for example. But Java, no. Java enforced in a rule. It's called the rule approach, not like indentation, not syntax, because Python, they just follow the syntax, right? Like, so the syntax has to be indented. But Java, I'm not sure if you're familiar with this, but if you write this, so let's go to, there is a slide for this, so I'll wait for it. So here we're talking about the ambiguity of else, what if statements are nested, as we said, and then we're also going to see an alternative semantic. Okay, we're going to talk about it in a bit. What do you mean by alternative semantic? Because when we talk about ambiguity, we're talking about semantics here, because maybe the syntax is clear, but there is an issue of understanding this code. So alternative semantic is to prevent ambiguity, we can do something, we're going to talk about it. Now let's take a look at this Java example, as we said. Okay, so Python, I helped you and I said indentation will solve it. What about Java? What will happen in this case? This else is for what? For which if? Michael. For the outer? Okay. Another answer. People on Zoom, you can also answer if you want. But with the mic, because I cannot check the messages. Do you all agree on the outer if? Based on what? Based on the indentation is the outer loop. If it's based on the indentation, that means the inner loop. Sorry, this if. That's what you mean? So Michael said it's for this one, right? For the outer. And then Brahim is saying, no, Java doesn't recognize indentation. So it's going to be for what? For this one before it?
I was thinking based on, like previously we said, if condition.
This one is not used by Java. This one is the ambiguous one. We said like,
that we can't do all statements at once. So the if statement will take the one that's directly under it, which is separated by the semicolon, and then the rest, it will just.
No, but else, when you see this else and if, these are special words, so they are not considered as a statement. Technically, in this case, Java have a rule approach, as I said. So they added a rule to make it easier. Why? Because in Java, compiler doesn't recognize indentation, actually. So they wanted to add something. So Java static semantic rule else matches with the nearest previous if. So that's their rule. So they said, you know what? We're going to make it easy on us. The else will match the nearest if, and that's it. Why they wanted to go to this road? Why didn't want to follow the indentation? Why? For the compiler. What would be a design approach for not allowing the compiler to look at the indentation? Because technically, if you make a small mistake with the indentation, like just a space, what's going to happen? A compile error right away. This is not very practical. This happens a lot with us in Python sometimes, just like small thing. So Java wanted to, you know what, we're not going to focus on the indentation. We're going to actually have our own rule. Now, if I want to force an alternative semantic, for example, I have this, but I want this else to be for the outer loop. How can I enforce semantic? Because now here, the default semantic is that this else will go to the nearest if. So how can I enforce a different semantic? I want this else to be for the outer loop. How can I do that? Brackets. Again, brackets will solve everything for us. Okay, so brackets. This is called enforcing semantics. To force an alternative semantic, compound statement may be used like this. I will just add these brackets and that's it. And also C, C++, C#, they all follow the same thing. So the C-based languages. Now, in Ruby, it's different. In Ruby, there's also another enforcement or another way to make sure things are good is by these end. They have like a special word for it. But when it comes to Python, it's based on indentation. So if I want to change or the semantic of this, what should I do? If I want this if else to be for this if, I'll just change the indentation and that's it. Okay? So nesting selectors design issue. So this is the second issue, the third issue. If I want to do a summary about this issue, what can we say? With the exceptions of Python and F#, indentation has no effect on semantics in contemporary languages and is therefore ignored by the compilers, okay? Except for Python and F#. The disadvantage of using a rule-based approach, so we said Java uses a rule-based approach, but what would be a disadvantage of this? Even if the programmer intended the else to match the first if, the compiler could interpret it as matching the nearest if, instead leading to unexpected behavior despite being syntactically correct. That's why usually Java will tell you, no, always use brackets. So this disadvantage can actually be easily solved, right? It's not like a big design issue. Why? Because you can just use brackets and you can get rid of this. Now, readability and reliability can be applied for both, for Python and for the C-based language. Both of them will have a bit of disadvantage or advantage for readability and reliability. When it comes to the readability, the use of brackets or a special word like end and Ruby for this purpose resolves the question of the semantic of nested seg. So if you have like a brackets or like special words, this is very good. For reliability, since the else may unintentionally pair with the wrong if, it increases the risk of logical errors in the program, which can lead to unexpected behaviors and bug. In this case, what? In this reliability, in this case, it applies to which part? If I'm using brackets or not? If I'm not using brackets, it will affect my reliability. But if I'm using brackets, I solve this issue. So that's why, guys, also one of the things that when they are designing the language, even though you will say, oh, okay, this may, I don't know, this may cause a problem. Like the disadvantage of this is that. But if you're able to solve this disadvantage very easily, like by brackets, it's not going to be considered a big disadvantage because the positive side effect of this is much better than just adding a bit of brackets. Now, in functional languages, you are allowed to do something like this. So we're going to say let y. So you want to assign y. Inside the assign, you can actually do an if condition. Okay, so this is in functional languages. Now, if we move to the multiple way selection statement, we're not going to spend too much time here, but this allows the selection of one of any number of statements or statement groups, as we mentioned. So let's check some of the examples and the C-based language. It's like a switch, for example, okay, or cases. Now, if we want to take an example in Python, that's the example that Michael gave. So you can use a two-way selector to what? To do the multiple selectors. Okay, guys? Then this is an example in Ruby. They also use case when, end. This is just a graphical representation. Why we're doing the graphical representation? Because originally, the theorem is based on what? If anything can be represented by a flowchart, can be solved with the selection and the iteration. So just like from a flowchart perspective, if we want to represent the if then else, it's like this, correct? So the condition, if yes, you do this statement. If no, you do this statement, and then the output. Now, if we have if and then, what are we skipping? The second one. We're going to just say if. We're having yes, so do this statement, and then no, just go away. Okay, so that's the idea here. Now, the abstraction principle of this, because again, how would this be super simple? Because of this thing. Even though it looks like this, but how can I visualize it, or how can I deal with it from an abstract way? Single entry, single exit. So again, if I minimize my language to only use single entry, I can solve everything much, much easier than what having multiple entry where I have to add lots of different conditions, different things when designing the language. Now, another flowchart, this is when we have the multi-way entrance. Now we'll move to the iterative statements. So that's the second one, which is based on the loops. The repeated execution of statements are compound statement is accomplished by what? Iteration or recursion, guys, right? So we're going to focus here on the iteration. General design issues for iteration control statements can be two main design issues. How is iteration controlled? And where is the control mechanism? So control mechanism, I want you to remember the word control mechanism is what is usually, for example, when you have the for, this condition, it's not just a condition, right? It's a control mechanism. Why? Because we have a condition, we have an iterator, for example. So this control mechanism, is it going to be based on counter, or is it going to be based on a logical thing? So this is the control mechanism. And then how is iteration controlled? There's just a few examples in different languages. So one of the types of controlled loops can be counter. So who can give me an example? Which loop is a counter-based loop? The for loop is a counter-based. Why? Because we're always having the I++, the counter, or whatever. Now, in languages like the C-based languages, use for loops with a clear start, end, and step values. Another language like Python uses something a bit different. It's still a counter, but what do we use in Python? The range, correct? We use the range. So control mechanism, in this case, where is the control mechanism? We said it's like the iteration, the condition, and the counter, and the location of this control mechanism is where usually in the header of the for loop. So usually it's included in the loop header, and this is some example, of course, of C++ and Python. Now, a bit of difference between languages is what? C++ differs from C in two ways. The old C, we said it doesn't use what? Boolean, correct? So in C++, you're allowed to use Boolean. But in Java, what is the difference between Java and C++ now? We already talked about it from a type perspective. The same as the if condition. Sure. Yeah, so in Java is explicitly Boolean. Again, the same idea like the what? The if condition. So in Java and C#, you cannot use the iteration. So if I want to take an example, actually in Java, if we try this, it will work fine, right? It didn't because I deleted everything. So I should have it here. It will work fine. But if I do this, I delete the condition. I just give it I. What's going to happen? Error. Okay, but this will not happen in C++. If you look here at this one, it will actually work fine, even if I just have I. Okay, so that means it's going to take this condition as what? As a positive condition. Okay, so let's go back here. Now, the only thing that I want you to take from this slide is that functional languages cannot do the loops. What do they use to imitate the loops? Recursion. Okay, because even in previous courses, like even a data structure, if you remember, we said, what do? We go for the recursion instead of having a for loop sometimes, just to not go with the O of and thing. So recursion can imitate actually iterations. Now, the logically controlled loop. What is the logically controlled loop? So what do we have other than for loop? No while. Why? Because the idea here is it's based on logic. So while this condition, keep doing this, right? So we're not going to talk a lot about the design issues, but the idea is very clear here that these are the while, or you can do while. Python, the same thing. Now, what is the control mechanism location? It can be either on the loop header or the footer, depend on what the do while. So if I give you a do while, and I tell you where is the control mechanism, it should be at the footer, not at the header. So now, if I want to talk a bit more about the control mechanism, some other things that will be part of the control mechanisms are the break and continue or exit. Why? These are also things that you can add to the while loop that they can control it, right? Like, for example, you can break, go out of the loop, you can skip, you can do things. There is a bit of difference between languages when it comes to these break and continue. So for example, in C, C++, Python, Ruby, C# have unlabeled. But in Java, also in Perl, they have labeled. Do you know the difference between unlabeled and labeled? Actually, I'll show you. This will be the last slide. So the unlabeled is this, like the normal one that you can see usually. So if I'm doing this break, which loop I'm breaking, and which one is continuing? The inner loop, correct? Inside this inner loop, I break here. I'm done from this loop, but I will continue the outer one. But if I use in Java, for example, I'm allowed to use labeled break. So what do you mean? It will be something like this. I'll have an outer loop here. So that's a label. Then I'll say break outer loop. It will break from the outer loop. So this is allowed in Java, actually. Okay, so that's the only main difference here between the programming languages. So I'll just do a quick vocab, and that's it. It's not very big chapter. So for the vocab, where is it here? Okay. People on Zoom, you can also join the vocab. Again, as I said, hopefully the next lecture, I'll try to combine the three chapters, this one and the previous two, into one vocab, and try to, refresh our memory, because we're going to have questions like this in the final. I need to give you like a Java code, and then you need to know which statement is. Like, you need to know these things, right? I think that's it. So, design question about control structure. Should a control structure have multiple entries? Should a control structure have multiple entries? Actually, single entry, as we focused on, is much more efficient. What is a way to apply multiple entries in control structures? Is it using the go-to statement or using the switch cases statement? By the switch case, we mean the multiple way. Which one? Switch cases statement is what? It's part of what? So if I go here, so this is one single entry, that's single entry. If I go here, that's a multiple way. That's similar to a switch. You still have a single entry. The multiple entry is only when we have a go-to, that I can jump. But even if I have switch or cases, it's still you're entering from a single entry and then you're splitting. So be careful. Multiple entries in control structures affect what? Readability, maintainability, or both? Both. Which are the programming languages in this list that don't allow multiple entries and they lack go-to statement? It's not like they encourage to not have multiple entry. No, they don't allow it at all. C++ and C definitely allow it, right? We gave an example. We gave an action example. We said C++ has the go-to. If you Google, you will see it, but it has for specific things. There's a need for it. That's why they're keeping it, but it's definitely not encouraged to be used in a while loop or something, unless there is a reason for it. If then, else, then else, then else, then else. is a what? Two-way selector or a multiple-way selector? Actually a multiple-way selector, even if it's using two-way selectors, but they are building a multiple-way selector. One of the design issues in the two-way selection statement is the type of the control expression, right? So some languages like C++, the control expression can be arithmetic expression, not just Boolean, and in other languages like Java, it can only be Boolean. Why? Which decision is better, not why? Which decision is better? So when you answer this, it's not in your opinion, right? Just like based on the books, based on the people who spent years deciding this, not on your personal preference. Of course, based on what we've learned, as we said explicitly, Boolean will be better. Why? We're going to see in the next slide why this is better. It's a multiple choice. You can have more than one. Multi-select, I mean, not multiple choice. Because all of them, it has adding clarity, adding type safety, better reliability, all of them, guys, correct? So don't forget this thing. What would be the output of the program, this program? What would be the output of it? This is a Java, correct? It's a Java language. So what is the output of the program? So that's why I'm going to do another WOOC lab. I'll add these to the quizzes. If I ask you a question like this in the fine, you need to know, because Java is something that you've been taking for at least four four courses. So you need to know. I'm not going to ask you about Perl, for example, or Ruby, but I'll ask you a question about mainly Java, Python, C++. So it will be output 2. Why? Who can tell me why? Alp. Yes, so if x is less than 3, it should skip both. Why did it go to the second one? Yeah, so not only from programming, from this lecture that we spoke, that we explained, not from just your knowledge. So from the lecture, we know that Java only supports single statement thing, not more than one statement, not compound statement. But if this was Python, this would have worked. In Python, we're allowed to have multiple statements. So in this case now, what will happen if I added the brackets here? What's going to happen? What would the output be? Blank, correct? What's that? It will be blank. It's going to skip it because now there is this block. It's this 2 is less, and then it's going to skip it. In the image, what if gets the else? This else is for which if? For count equal 0 or for sum equal 0? In Java again, because it's different between some programming languages, as we mentioned. Of course, it's count because we said in Java, there is the what, the rule approach one. It always the else going to go to the nearest if, unless there's a bracket. If there's a bracket, then it's going to be called what? Enforcing semantic. We're enforcing a different semantic in brackets. And that's it. Let me outer if, yes, okay. So let me just stop recording. Where's the recording?